लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम। देखो ये जो लॉ है, लॉ ऑफ कंजर्वेशन ऑफ लीनियर मोमेंटम, एक्चुअली इट स्टेट्स नंबर फर्स्ट, द टोटल लीनियर मोमेंटम ऑफ एन आइसोलेटेड सिस्टम रिमेन्स कांस्टेंट। आइसोलेटेड सिस्टम मीन्स मतलब जिसपे कोई इफेक्ट नहीं हो किसी और चीज का। सो द टोटल लीनियर मोमेंटम ऑफ एन आइसोलेटेड सिस्टम रिमेन्स कांस्टेंट, या हम इस तरह भी इसको डिफाइन कर सकते, टोटल लीनियर मोमेंटम फॉर ए बॉडी रिमेन्स कांस्टेंट इफ नो फोर्स या नेट फोर्स एक्ट्स ऑन it is zero. If net force acting on a body is zero, then the total linear momentum of that body remains conserved या constant। तीसरी इसकी डेफिनेशन ये भी है, the algebraic sum of momenta of an isolated system of bodies along a straight line remains constant and not changes due to their mutual action and reaction. So these are these definitions of this linear momentum. The total linear momentum of isolated system remains constant first. Number second, the total linear momentum of a body remains constant if net force acting on the body is zero. Number third, the algebraic sum of momenta of an isolated system of body along a straight line remains constant and not changes due to their mutual action and reaction. Now consider two bodies A and B, moving with initial velocities u1 and u2 along a straight line. Okay. Let this the velocity of the first body, that is u1, is greater than u2, which means then after some time the body will collide with each other. Let after collision the bodies move with velocities v1 and v2. So initial velocity is u1 and u2 of the body A and B, and final velocity is v1 and v2 of the body A. Let the time of relaxation, yeah, the time for which the body remains in contact, that is delta t. Let that is delta t. So ठीक है. So we have two bodies A and B moving along a straight line with velocity u1 and u2. Then after some, since u1 is greater than u2, after some time the body will collide with each other. Let delta t is the time of relaxation, or time for which the two bodies remain in contact. Let after the collision, the body, their velocity changes. Body of this velocity, final velocity of A is v1 and B is v2. Now when the two bodies will interact with each other, when they will collide with each other, so they will exert force on one another. Let FAB is the force exerted by A on B. This is the force A and B. Similarly, let FBA is the force which exerts B on A. ठीक है? As we know that there is no external force acting on the system. Therefore, the total force is zero. Therefore, FA plus BA, this is action and reaction, it is equal to 0, or FAB is equal to minus FBA. This is in accordance with the Newton's third law of motion. क्या है third law of motion? Third law of motion is to the every action there is equal and opposite reaction. This FA is equal to FBA but in opposite direction. ठीक है? Therefore, the linear momentum before collision क्या होगा? Total linear momentum, it is m1 u1 plus m2 u2. ठीक है? And after collision क्या होगा फिर? m1 v1 plus m2 v2. ठीक है? Now what will be the rate of change of momentum of body A? Rate of change of momentum of बॉडी ए क्या होगा? वो m1 v2 minus m2 u2 by del t. ठीक है? So rate of change of momentum of body B, it will be equal to m2 v2 minus m2 u2 by del t. ठीक है? So the force on B is equal to, it is equal to FBA. So FAB is equal to minus FBA. Putting these values in this is FAB, this is FBA. The rate of change of momentum is directly proportional to the applied force. This is the force, this is the force. Okay. Therefore, M1 V1 minus M1 U1 by del T. This is M1 U1, not M. Is equal to M2 V2 minus M2 U2 by del T. Okay. Or it will be equal to M1 V1 minus M1 U1 is equal to M2 V2 minus M2 U2 simply, or M2 V2 minus M2 U2. ये इसको मैं माइनस पाई निकालूँ इज इक्वल टू M1 V1 minus M1 U1. Yeah, I will write minus M2 V2 plus M2 U2 is equal to M1 V1 minus M1 U1. Yeah, I will write M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2. This is the initial momentum. This is the final momentum. So initial momentum is equal to final momentum. That means momentum before collision is equal to momentum after collision. This is called law of conservation of linear momentum. We state that the total momentum of a body or system, isolated system, remains constant if no external force acts on it. This is the law of conservation of linear momentum.